Okay, hi everybody. Привет, Novosibirsk. I hope that was not too terrible. Thank you. First time I've been clapped for that. So my name is Ramon, and for the next 40 minutes, I'm going to talk to you about why you might not need classes in JavaScript. But before we get into the topic, let me tell you a little bit about me. So I'm a front-end web developer from Madrid, Spain. I work at a small startup called Undefined Labs, in which we build developer tools to help teams ship better code faster. We are currently working on a tool called Scope that is focused on testing visibility and is especially useful in microservices environments. And I've seen some talks related to that in this conference, so that might be something that interests you. So if you want to learn more about that, you can go to scope.dev and request early access. Besides that, I work with JavaScript and React, but and I really like those technologies. But what I really like above all is the web as a platform. I love its promise of an open medium accessible to all. And I really like also the community, the web community around it. And that's partly why I like to go to conferences like this one, and to give talks. I also volunteer at a lab, which is coding bootcamp for women in Madrid. So you probably can already tell that I care quite a bit about diversity and inclusion in our community. So let me take just a second to say that one of the things that I would really like to see as part of this inclusion effort is conferences stepping up their game when it comes to these issues. So things like having an enforceable code of conduct so that everybody can feel safe, or making an active effort to feature more diverse speaker lineups. And some conferences already do this, and that's great, but I would really like it to become the norm rather than the exception. And you as attendees have actually the power to change it, so because you can demand these things from the conferences you would like to attend. So let's see if we can do better in the future. If you want to reach out to me later, that's my Twitter account. My DMs are open, so you can just write to me. Whatever you want, questions, feedback, they would be greatly appreciated. And with all that being said, let's get started. So what are we going to discuss today? First, we're going to see why we got classes introduced into the JavaScript language, to give you a little bit of context and history. Then we'll go on to check the most common issues and pitfalls that you might bump into when working with classes. Later, we'll see some alternative patterns to using classes in JavaScript. And finally, we'll review some recent case studies of popular JavaScript frameworks moving away from classes. So you can see that it's not only me talking here, but that there's actually community moving around this issue. So why did we get classes in the first place? Classes were introduced into the language over 4 years ago. They were part of the 6th edition of the language, known as ECMAScript 2015, as you probably know. And when we think about classes, we tend to think about object-oriented programming, right? But it turns out that object-oriented programming, JavaScript already had a mechanism for object orientation right from the very beginning. It is the prototype. So if we already had prototypes, So if we already had prototypes, then why did we get classes again? Let's look at an example to understand a little bit better. Here we can see a counter class implemented with prototypes on the left and classes on the right. And we're going to be using this example along the talk, so you can take a good look at it, but it's not too complicated. It just gets an initial value in the constructor, and then it has a method to increment the counter and another one to reset the value. It's simple. So in this case, the class on the right, it looks a little bit cleaner, but I'd say it's not such a dramatic difference. However, when you try to do inheritance with prototypes, things get much uglier and messy. Here's a step counter that inherits from the counter that we saw before. And when doing this with prototypes, well, as you can see on the left, we need to do some weird things, whereas with classes on the right, we just need to use the extends keyword and call super on the constructor, and we are done. The syntax is much nicer. So based on what we just saw, we could say that we got classes in JavaScript as an improvement over prototypes, at least in terms of syntax, as we've seen. But I would argue that there's probably a more important reason, and it's that classes are familiar for new people coming to the language from other languages. I don't know if you've heard, but JavaScript has become quite popular in the last few years. So introducing something like classes, that is a concept already familiar to people and that already existed in a lot of other languages, seemed like a good idea. So classes don't seem so bad, right? There are legitimate practical reasons to have them in the language. They are better than prototypes, at least in terms of syntax. So what's the problem then? Well, there are actually a few problems, so let's get over them. The first and most important one for me is that classes in JavaScript create false expectations. We just said that the reason to add classes to JavaScript was because they are a familiar concept. But the thing is that classes, the way they work in JavaScript, it's not the same as in other languages. So we are using the class word for something that doesn't quite behave as you would expect from a class, which is a little bit weird, a little bit disconcerting. Let's see an example of this. Here we have our counter class again. So let's say we instantiate it with 0 as the initial value, then we call the increment method, and then we log the value, and okay, it's 1. Everything's working fine. But what happens if I now do this? First notice that, as you might know, JavaScript classes are basically syntactic sugar over prototypes. So you can see here that I can actually access the underlying prototype, which we could call a pretty leaky abstraction, at least. But besides that, the thing is that the prototype is a living object, it's an instance on itself. So even though it's been changed now and that we instantiated a counter before, if I now call the increment method, it doesn't go up to 2, it goes up to 0 because the prototype was modified, and it's a live thing. And that's the core of the issue, that typically a class defines a type that can be later instantiated in runtime, whereas a prototype in JavaScript is actually a living object instance itself that is then referenced by other objects. And that's the key word, living. Prototypes and instances themselves. So you can modify them, and the changes will affect previously instantiated objects. Unlike classes, definitions in prototypes are not statically copied at declaration time. And again, since classes are syntactic sugar over prototypes, they behave this way as well. And that can be really confusing for someone used to classes in languages like Java, for example. Also notice that in the example from before, I could access the value property from the outside. If we have a counter object with its own increment method, we might want the value to be private. And here's another issue with classes. They lack a lot of features that we have in other languages. We don't have private members. We don't have static members. We don't have decorators. There are proposals for all these things, but they're not part of the standard yet. They will likely take some time to land still, because they are tricky to implement on top of prototypes. If you use TypeScript, you get some of these things. You get public, protected, private fields and methods. You get read-only properties, even abstract classes. But that's in TypeScript, not in the JavaScript standard. And actually, another problem on top of all this is that TypeScript implements these things in a very different way to the way they are being implemented for ECMAScript. So that's going to be an issue at some point. They're going to need to converge. And honestly, I'm not even sure we want or need some of these things. Take static methods, for example. They make sense in languages like Java, where everything needs to be a class. But in JavaScript, you can define a standalone function and just use it from wherever you need, including from inside a class. So there are, for sure, some use cases, but there are not as many as you might think. And we're introducing all this complexity into the standard to implement all these things. Whereas in most cases, you could do it some other ways, not that necessary. And then besides this is the context binding problem. Handling this keyword in JavaScript is confusing and very error prone. And these kinds of problems with context show up with asynchronous code, which is basically everyday code in the browser, so you are bumping into this all the time. Let's say we have now this button class that just gets a click handler. We are now instantiating a counter, the same counter we were using before. And we use its increment method as the click handler. We are passing it to the button. So the idea here is that whenever you click on the button, the counter will get incremented. That's easy to get. Well, what happens is that the counter is not actually incremented. And if we look at the button, we see that it has a value property that is not a number. That's weird. Some of you might already know what is happening, but the problem is that the increment method uses the this keyword internally to access the value, the property value, and increment it. But and we're passing it as the click handler to the button in this line. But the this keyword in this line is actually the button, not the counter. So button.value is undefined, undefined plus 1, not a number. That's why this happens. So we need to bind the inc method to the counter instance. We can do it like this in every call. This looks like we are going to forget at some point, so okay. This is our problem. We have to do it every time. And we can do it either with a bind method or with an arrow function. But it's better to move it to the constructor of the counter class. That way, we don't forget. The syntax is a little bit weird, though, but it doesn't matter. We can use the class field arrow function proposal and write it in this way. The syntax is nicer. It does exactly the same. Great. We've solved our problem, right? Well, the problem, again, is no matter which way you do the binding, if we now look at the prototype of the counter, we'll see that we get the constructor and the reset method, but the increment method is not actually there. And this is because the increment method is no longer a class method. It's an instance property, and we've just seen this. We've just seen this before. Here, what we're doing is we are getting the instance, adding an increment property, and then assigning it to the increment method in the class binded. So the bind method creates a new function effectively. So yeah, it's not part of the class anymore. We are basically adding to every new instance this inc thing in runtime when it's constructor. So again, classes are supposed to be a blueprint, and instances are supposed to reference the methods in the class. But here we are creating a new function for every instance, which is, again, not what you would expect in a class from other languages. And this also can have some performance implications, but I would say that those are very, very minor compared to the other problems that this creates. Finally, on top of all this, classes are harder to deal with for tools. They don't minify very well, which results in larger bundle sizes. Method names, for example, cannot be safely minified. Most minifiers just leave them as they are, untouched. Also, automatic death code removal of class methods is not easy. It's much easier to do that with functions too. It's easier to remove unused functions than class methods. And there are also, classes are not very friendly to some advanced techniques either, like ahead of time compilation. They make it harder, and hot reloading. It can be unreliable when using classes. Okay, so we've seen why we got classes. We've seen the issues we might find with them. So let's say we want to avoid them, at least in some cases, because of the problems we've seen. But we surely don't want to go to prototypes, right? Because classes are just syntactic sugar on top of them, and prototypes is just same problem, but with a weirder syntax. So what's left? Well, what's left are just functions. In JavaScript, we can take advantage of core fundamental features of the language, like closures, to do similar things to what we do with classes, but only with functions and without a little bit of a different mindset, but it's mostly the same. And we can emulate object-oriented programming features, typically implemented with classes like inheritance, encapsulation, polymorphism. We can also do implement some design patterns like singletons or factories. We are going to see examples of all of this. So let's take a look at how we can leverage closures to do these things. First of all, closures help with encapsulation, one of the issues we have, that we couldn't have private members. So going back to our counter example, we now have a create counter factory function. It's a function that returns an object, an instance. And first we can see how we don't need to save the initial value anywhere in the instance. So we are just getting it as a parameter, and then in our reset method, we are using it right away. And due to the way closures work, this initial value is binded to the instance return, and you don't need to do anything special. And for the same reason, the counter value, it's now private. We are declaring this constant here, and in order to read it, we need to return a method in the object that we are returning to get the value. But if we didn't have this get value function, we couldn't actually access the value from the outside. So we are effectively getting private members with this. I'm sure one concern that you might have is that unlike classes, there's no reference here. We are creating a new object all the time. But I would say that's not too important. First, because they're not such a problem. Like, they are very cheap. You can have a lot of, in order to reach a point in which having a lot of instances is a problem, you really have to have a huge app or a very specific use case. And also with classes, we still need to bind some methods. So we are actually creating new functions, not for all the methods, but for the ones that are binded, we are doing the same thing. We are creating new functions. So it's not such a problem. And in return, we get private members, as we've seen, and we also avoid issues with the this keyword, because we're not using it. So if we're not using it, there's no issue to be had. This is the button example that we saw before. Now we are using a create button, factory function, same idea, basically the same code. Everything works without doing anything, without needing to bind or without needing to do any other magic. And this might look like a very simple example, like something that you could say that it's not so useful, but it's actually a pattern that is actually relevant and useful in real life. Let's say, for example, we have something like this, a class to access some API. And this API needs a token for every request. So what we do is, we don't want to have a bunch of functions and be passing the token all the time. So we write something like this, movie API class that gets the token in the constructor, saves it on the instance, and then when we call this add favorite method, for example, we can access the token that was saved when the constructor was called. And we use it like that. New movie API, we pass the token, and then we can call the methods right away. Well, we can do this applying the idea we just saw. We can do the same thing with a function, create movie API. Same idea. It gets the token. We don't need to save anywhere, because again, due to the way closures works, we just return an object, the add favorite object, and we can access the token right away. And the way we use it is really similar. Instead of new movie API, we just call create movie API with a token. So it's almost the same. But we don't have this problem of having to bind things and remembering it. Object composition is another powerful concept that we can use. It helps us implement equivalent patterns to inheritance and polymorphism in a different way, but still the concept is the same. So here we have a create-based counter functory function. It's almost like the create counter that we saw before. The only difference is that instead of the increment method, it now has a set value method. So the idea is that this will serve as a base class, so to speak, that we are going to use to build other counters on top, the ones that we are actually going to use. This could be a private function living in some module. So now based on that, we can recreate the step counter like this. We call the create base counter, and we basically get all the methods that it has, all the properties, but set value. Because we don't actually want to expose set value. What we do is we use it on our increment method to set the value of the counter, but it stays private to the step counter. So we are basically returning the methods that we saw before. We're returning the reset, and we are returning the get value in this rest constant that we see there, and then we are adding to the instance the increment method, which uses set value internally, but the set value itself is not returned. And like this, we can do the create counter that we had before as well. Same idea, only we use 1 for the step counter, and we could also combine them in many different ways. Like we could define the counter based on the step counter, but with 1 as an argument. You can mix and match all you want. And we have here a similar thing to what we had before. We can even override methods. If create base counter, for example, already had an increment method, the way objects work in JavaScript and the way the spread operator works, even in this rest counter, we have the increment method. We are defining it again below, so it would be overridden. So you can do that as well. And then function composition and higher order functions are some other resources that we have in our functions toolbox. And we can use them to implement patterns similar to decorators or mixins. Let's look at this. This is a higher order function, which is just a function that returns another function. And it's called with login, because what it does is it logs to the console the arguments that the original method was called with, and then calls the original method. So to use it, we just get the function that we want to decorate, pass it to the with login function, and we get back our decorated function. It's a little bit more verbose or more explicit than using the add syntax for decorators in classes, but it works. Finally, in modern JavaScript, we also have modules, and they provide encapsulation again, and can also help implement some design patterns thanks to that. For example, a singleton. We were actually talking right before this talk with someone that was asking about how we could do a singleton without classes. Well, if you use JavaScript modules, it's as simple as this. There's an 11-line module. The only thing that it exports is the create a singleton counter function. And what it does is we have an instance constant that is private to the module. Notice that it is not exported, so it cannot be accessed from the outside. And what we do is when the create singleton counter function is called, if we didn't have an instance, we create one and we save it in this variable. And if we already had the instance, we just return it. So this is an easy way to have a singleton using modules. You can do singletons with classes in JavaScript, but if you want to do them covering all the edge cases, it can get a little bit tricky. You can look up for the code online, and there are some rough edges. So with this, it's relatively easy to do. It's just straightforward. Okay, so as I was saying in the beginning, is this just something that I'm obsessed about with for some reason? Or is there movement happening in the community around these issues with classes? Well, the thing is that there is some movement, and there are examples of popular JavaScript frameworks that are moving away from classes. So that's what we're going to see now. The most popular one probably is React with its hooks. React already had a class-based API to define components for the web. And one of the problems with that was that they had a function-based API and a class-based API to define components. So whenever you wanted to add state to a component or to add side effects, you had to rewrite your component from a function to a class, which was a pain in the ass. So with hooks, what they did is basically provide you with functions that encapsulate this state, and you can use them right from your function component, so you don't need to write classes anymore. This would be a simple example, a counter again. We are calling the useState hook, passing the initial value, and what this gives us is the value and a setter. And then we use it in our code. And notice how, for example, on click of the button, we are using setCounter right away, and we are not doing any binding. If this were written as a class with React, we had to remember that the increment method needs to be binded so everything works. But here, because everything is inside the function, it's a single closure, you can reference everything without these problems with the this keyword. And another interesting case, and I think this is actually more interesting, is Vue. Vue didn't have a class-based API to define classes, and they wrote a proposal for it because the community thought it was a good idea. We had the React example. So they came up with a proposal, and at some point they decided to drop it because they found some problems that at some point they thought that the problems were more than the advantages, and they decided to drop it actually in favor of something that they call the Vue Composition API that is heavily inspired by React hooks, and it's a really similar idea. This would be an example of the same counter with Vue. And you can see there that there's a setup method, and we have this Vue reactive thing, which would be the similar thing to useState that returns the state, and then we have the increment method to increment it, and then we use it on our template. So this is similar. Again, no need for a class. And the interesting thing, especially in the case of Vue that didn't have a class-based API, had a proposal for it, and then finally decided to drop it. These two frameworks decided to move away from classes because they found now that they had some issues, some of which we've already talked about, and some of which we haven't talked about yet, and that's what I want to talk about now. So first, in the case of Vue in particular, they realized that classes mix concerns. If you have, for example, you have a component that needs to attach an event listener to some DOM element, and then on a mount it needs to be removed. The problem we have here now is that in frameworks like React with classes, you have this component in mount method, and you need to add the event listener there. And then you have a component with a mount method, and you need to add the remove listener call there. So the problem is that we are not grouping code by feature, but by at which time in the component lifecycle things happen, which is not really natural. And in this case is simple because we only have an event listener, but if we had like 3 different event listeners and then a network request and then some other thing, we'd have like 3 different pieces of logic scattered all around the component, and it can be difficult to follow. And it happens a lot. You will probably at some point decide that you don't need the event listener anymore, so you will remove the add event listener, but you will forget to remove the remove event listener because it's not everything is the logic is not encapsulated. It's spread around the component. So the good thing with things like Hook or the Vue Composition API is that we can group our code by feature And since there are not methods, since there are not some special methods that need to be used in a class, there is just functions. We can actually extract that code into a function outside of the component. So in the example of view, we could take everything that is in the setup property, because it's just functions and constants, and move it to a function outside and call it useCounter, for example. And if we had in this component some other functionality, we could extract it to some other function, give it our name, and we would call it from the setup. With the additional benefit that we can now reuse that between components. We can have that thing in some other file, and we can import it from different components. So we are really encapsulating state and side effects that pertain to the same feature in the same function, which is really nice. Actually related to this, classes lead to convoluted patterns, because if we want to reuse, if in the example before, if we wanted to have this component that adds an event listener and then removes an event listener, the thing is that we need to, it's a component, so we need to render something. But the problem is that we don't really want to render anything. We just need to encapsulate that logic. So in the end, we have patterns like higher order components, mixins, render props. Very complicated. I mean, they're really useful, but the first time you look at them, they're like hard to grasp, and they're complicated and they're cumbersome. Whereas with things like, whereas with APIs based on functions like these two we've seen, we don't have that problem. We just define the function somewhere else and we just call them. They work much better. And again, this leads to the next point. Well, also something I forgot is that patterns like that, they're not only more difficult to follow, they are also had some problems, like if you use a higher order component and you are injecting props into a component from different ones, the sources are unclear, because now you don't know which prop is coming from which mixin or from which higher order component, and it could also happen that the names clash. So that's an actual problem. And related to this, because function-based APIs leads to less convoluted patterns, it also means that they are more type-friendly. Since we're using mostly plain variables and functions, they are easier to type with any static type system like TypeScript or Flow. And sometimes you don't even have to, because type inference works way better when you have that. These convoluted patterns we were talking about before, they are harder to type, because you will have to you'll have to use some special syntax from TypeScript or Flow to say, okay, these props are coming from this higher order component, and then I need to define that this accepts like the props coming from here, and then it's some props. It's if you've ever had to do that, you know it's quite a mess. So that's another benefit of these approaches. And this is all these three things, which I would say are huge, they are only based on component frameworks. This is actually on top of all the benefits that we previously mentioned, like the bundle size. The fact that we're using hooks and we are not using classes means everything is a function. So the bundle size is actually smaller, because they minify better. So that's an extra benefit that we get from it. Okay, so that was a lot, right? Let's do a quick recap of the main points of the talk, so at least you can remember something tomorrow. First thing and most important one, and I already mentioned it before, adjust your expectations when working with classes. I'm not saying you should never use classes. There are some valid use cases for classes in JavaScript, but you need to know that they do not work as in other languages. So if you don't know about prototypes, you should probably learn a little bit about them. And this is an especially important issue when you are onboarding people coming from the backend, for example, that they now need to work on this React web app or this Vue web app or whatever it is. And they think that these classes are, oh, this is great, because they are familiar. They're just like Java classes, the ones I've been using until now. And then they bump into these things like, oh, but why is this not working? And it's so hard to explain that. I know, oh no, you actually need to do this arrow function craziness, and they're like, why? And explaining that is really hard, because it's like a rabbit hole, because you really need to get down to the prototypes to explain all that. It's very confusing. So even if you use them, you really need to know what you're doing. Then, of course, watch out for issues with context and the this keyword. So remember to bind your methods with dealing with asynchronous code. I know I have to do it, and I forget all the time. So that says something about the quality of the feature. If I know, and I still forget every time. And also look out for encapsulation issues. We saw before that the fact that we don't have private members. Use Babel to if you want that feature, or maybe use something like TypeScript. And finally, unless there are real performance concerns, which is rare in apps, but it could be, you have a very particular use case where you have tons of instances, but like a lot of them, or if your framework imposes you using classes, which is not so common anymore, as we've seen. But unless one of those things happens, consider using functions, closures, modules, object composition, function composition. They're all powerful, and they feel very natural to the language. And the thing is that closures, in particular, are in fact so fundamental to the JavaScript language that you are going to have to learn them anyway, because you are going to bump into that. So you might as well take full advantage of them, and at least sometimes try to consider just using functions and implement some of the patterns that we've seen. And that's all for me. Thank you. Again, that's my Twitter handle. If you want to tell me anything, DMs are open, and this is the feedback form. I would really appreciate some feedback. Thank you. I think we have time for some questions.
Hi, thank you. So we heard a lot of stuff, why shouldn't we use classes and all that. So now obvious question is, why should we? So,
yeah,
so where should we? Okay.
I mean, the first thing I would say is that you don't need to. So you don't want, it's a feature in the language, and we don't need to use every feature in the language. I rarely use generators in JavaScript, and they're a thing. So you don't need to. If you want, if you like the syntax, I'd say they are fine when you know that all your methods are synchronous. If there's not asynchronous code involved, I'd say it's fine, because you are not going to have these issues of binding and everything. But at the point in which you start to have asynchronous code, I see very few reasons to use classes in general. Or if you're using a framework like Angular that forces you to use, that's the way it is. You cannot do anything about it. But yeah, hope that answers your question. Okay. Is it working?
I have this question about, like, for example, singleton example. Yes, it is a way to go around singletons, but don't you think that it looks a little bit artificial and maybe less readable for people who are not familiar why you're doing this? Because you need to explain why you're creating
I'm sorry, there's noise outside. I don't hear you very well. Can you repeat, please?
Can you hear me now?
Yeah.
Don't you think that some of these ways, like for singleton, for example, they look a little bit artificial and not readable for people who are not familiar why you're introducing a separate method to go around the singleton?
I mean, I agree that it could be a little bit hard. On the other hand, I also think that if you do it with classes, you are going to have problems anyway. I mean, I don't think there's no perfect solution, but I would say that once you know what JavaScript modules are, and the fact that if you define a constant in there, it's not a global thing, it's only global to the module, I think that is fine to read, and it's not so difficult to understand. Whereas with classes, you're going to have all these problems we've been seeing, like the binding. And I think for someone not familiar to the language, I would think that is easier to learn than having to learn this keyword and the binding and all that. Because I can explain that, like, oh, see, this is private, and then you call this method, and we assign it. Okay, fine. But other things like, no, you need to bind it. But why? No, because this weird thing, because the prototype is a living object, and then you change it, and it's like their head explodes. So
makes sense, yeah.
Thank you for the question. Anything else? No?
Okay, so let's thank you, Ramon.
Thank you.
Yeah, and you are welcome to give feedback for Ramon's presentation, and you can find Ramon on the 3rd floor if you still have questions after this talk. So, thank you.
Can I? Yeah.
You can switch off. Everything was good.
Glasses first. Yeah. I almost forgot. Okay, so it was 3rd floor. Sorry? 3rd floor, right?
Yeah. So you go upstairs, and there is this area somewhere, there's sofas. Don't want to ask publicly.
Yeah, because that happens. Great, I'll go there. Thank you.
Следующие 4 по расписанию, правильно? Это не мой компьютер. Пароль. Я обычно выключаю мой пароль, никто не будет сколько символов.
Не страшно.
Да.
Зеленый, поговорить что-нибудь?
Раз.
У тебя минут будет. Где-то там. Окей. Я на 30 минутах показываю здесь. Да? Потом на 5 минут. На вопрос. Еще придет что-то 5 потом придешь, включаешь на тему, кто-то не готов. Обычно сколько вот принято? Я могу чуть дольше, чуть меньше. Ждать 2 недели? Не, ну 40 минут и 5 минут на вопрос. Потом готовить. Так, смотри, еще нежелательно занято кабинет и начинает на экране у тебя комфорт на черном фоне, на белом, на белом. Так, ну нам надо сейчас что? Давай выведем что-нибудь на экран, что... Давай, сделаем. Сделаем качество. А ее тут и нету. Да, да.
Нигде нет.
Ну, может еще на этой, кто она? Ну, где вот регистрация там? Ну да, так, нет. USB у нас, правильно? Должен был. Так, тут такой есть момент, что нужно сфокусироваться, да, на... Ой. Да, на ней сфокусироваться. Так, сейчас я включаю. Он. Если надо показать несколько, ну, если на экране. Окей, все круто. Так, у нас еще примерно 15 минут. Вот, ну проходи так все. Часто выступаешь? Да. Микрофона.
Раз. Слышно меня, да? Немного дожило до 4 часов. Ну ладно. Меня зовут Игнат. Я работаю в компании Cloudflare. Кто-нибудь знает про Cloudflare? Или да, кто не знает про Cloudflare? Не знает? Очень интересная компания. Если у вас есть веб-сайт, обязательно проверьте, чем мы занимаемся. Мы все предоставляем бесплатно. Я доклад буду делать на английском языке, потому что я на самом деле не знаю, как много чего здесь говорить по-русски, поэтому простите меня, если что не так. Если что непонятно, спрашивайте, и я переведу. Okay, so today we're going to talk about how to make a software fail on ARM64. First, a little bit about myself. My name is Ignat. I work for Cloudflare. I do performance and security. I'm kind of passionate about cryptography, and I also enjoy low-level programming, so like Linux kernel, bootloaders, and other very low-level and scary stuff. So first of all, why? Why do we want to consider another CPU architecture in your cloud, right? There are a couple of reasons. One of them, the first one is probably the most important one, is vendor lock-in. So people talk a lot about like how to unlock yourself from AWS, how to do like cloud agnostic infrastructure, but no one talks about really how to avoid Intel CPUs, right? Because everyone runs on Intel. Who here doesn't run code on Intel? You run on AMD, right? Okay, good. The second potential reason is energy savings. So like we heard that some CPU architectures can be more power efficient. And for example, this is Cloudflare network today. I don't think you see do you see the map, world map? So we run around like 200 data centers across the world now. And imagine if we can be at least a little bit more power efficient, we can probably save enough power to power a like small African city or something like that, right? With power efficiency, you can also cut money. Like you have to pay for power. If you use less power, you have to pay less, as well as if you can run on a different CPU architecture, maybe your choice of hardware is more wide, and then you can select more cost-effective solutions for your server. There is also this. Who doesn't know what this is? You know or you don't know? Yeah, so this is Meltdown Inspector, right? So initially we were just like considering, oh, should we do ARM or should we not? But like when these attacks came out, it was like, well, we definitely should seriously consider another CPU architecture. And like to be honest, ARM64 is somewhat vulnerable to Spectre as well. But we were thinking like, what if there'll be another hardware attack which cannot be patched by software anymore, and it will be so severe that we have to shut down all our Intel CPUs. If we have like at least 50% on ARM, we can still stay in business, right? So this is like why different CPU architecture in general, why ARM64 specifically. So basically it performs well in the mobile and IoT space with all the smartphones running. Modern smartphones run on ARM64. They're potentially more power efficient because ARM CPU architecture was originally designed for small power efficient devices. Nowadays it has huge developer community, again thanks to the boom of the mobile market. What's important for us, nowadays it has first-class support in Linux. In Cloudflare, we're primarily a Debian shop, and like Debian from version 8, Jesse, has ARM64 as a primary architecture. Therefore, it receives the same amount of attention and support as the x86 one. ARM has established tool nowadays. A long time ago, when you're considering some other non-x86 architecture, you had to go to some dodgy websites to download compilers or something else. Now you can just get it from your Linux package manager. They're all available and official and working really well. Why ARM64 specifically? Because it's more than 32. Where in mobile and IoT space, you can still get away with 4 gig of RAM on your device. Like in the server scenario, your server will probably be useless if you have only 4 gigabyte of RAM, right? And it kind of mitigates the risk, right? So like we didn't want to consider like AMD, which is like slightly different from Intel, but the same architecture. We wanted something completely different and to mitigate potential hardware vulnerabilities. And ARM architecture is completely different from Intel one, right? So yeah, we did some initial benchmarks. And so we like had a synthetic benchmark which kind of represent our production workflow. And we had a test CPU from Qualcomm, test server CPU called Falcor Core. So we decided to test its performance. And so this is our current generation Skylake Intel CPU. This is our previous generation Broadwell CPU, and this is Falcor. And this is kind of Nginx based benchmark with our custom logic in Lua on top. And you can see here, so Falcor actually came second, so it won. It is better than our previous generation Intel CPU. So our current, it's only 1,000 requests per second behind our current generation Intel CPU. But during this benchmark, we also measured the consumed power, and to serve 15,000 requests, ARM consumed like half the power compared to our current Intel generation, which is kind of good. So we think it's a good to trade off 1,000 requests per second for like 50% of power savings. So we were very satisfied with this benchmark, and the next thing, like, okay, let's put it into production. And when we put the server into our data center, so it looked like something like that, because it doesn't work. It doesn't have any software in it, right? So from this point now on, we went to our developers and we say, hey, developers, from now on, please compile and all your software, all the projects you're managing to ARM64 as well. And here where the problems came up. So the first class of problems we encountered when we tried to port ARM64 is basically compile time problems. When you talk to your developers, what their initial concern will be probably, it will be very hard because to port software because there is a lot of assembly in it and like architecture-specific stuff. It's actually not true. During our long and rather painful porting process, we never encountered this specific case. It was always something else. The real problem now with your developers when you're adopting a second CPU architecture is that now the production architecture is not the same as a developer architecture. So you have ARM64 servers, but developers still have x86 laptops, right? And the typical solution to that is like, how do they produce software for ARM64? And the typical solution to that is cross-compilation. Anyone here doesn't know what a cross-compilation is? Whoever used cross-compile? Oh, nice. I'll briefly explain the process. So in a typical of native compiler, imagine you have a source file, you have your developer laptop, which is x86, it runs a compiler, you feed your source file to the compiler, it produces a binary, and you basically install that binary into your production machine. You can also run it locally to run tests. Cross-compiler is a little bit different. So again, you have your source file, you have your developer laptop. It's still x86, but it runs a different kind of compiler called cross-compiler, which produces a binary for a different CPU architecture. And you install it to your production ARM64 environment, and you can't run it locally because your x86 laptop does not know how to run it. And to explain all the problems we encountered with cross-compilation, you need to grasp some basic cross-compiler terminology. So in cross-compiler world, the host is the architecture where the compiler runs. It's usually the developer laptop, x86, and the target. The target architecture is for which the compiler generates machine code. So this is your production architecture. In our case, it's ARM64. And there is like a particular case where host equals target. They call it native compilation or just compilation, which we're used to, which is actually a small subset of a more general cross-compilation. Here is like a small example. Consider it as a demo. I promise I copy-pasted it from a real terminal. So if you have a source file, you want to compile it, you just invoke your compiler, it produces a binary, you can inspect the binary, you can see that it's for x86 architecture, and you can test it, right? You can run it. If you want to port this code to ARM, you just replace your compiler with a cross-compiler, it produces a binary, and now you can see that this is a binary for ARM64 architecture, and you cannot run it locally because, again, your developer laptop does not know how to run ARM64 code. So most of the compile time problems come from trying to use cross-compilation on the projects which do not support it. And the first symptom we encountered is both broken native and cross builds. We actually, like to explain our thought process, we actually wanted to move fast. So we wanted to try to cross-compile our software, and if it doesn't work, we had a dedicated ARM64 box for developers, so they just can copy the project there and try native compilation, but ARM to ARM, to see if it's a problem of the code or it's a problem of the build system. So in this case, both native and cross builds were blocking, so we cannot cross-compile the project, and even we could not natively compile it on an ARM64 machine. And you usually get an error from your build system, looks something like this. And the cause of this is probably your build system has hard-coded architecture-specific flags. So we're mostly using makefiles. If you use makefile build system, you will kind of find some line like this or this in your makefile. So MSEE2 is a instruction extension for x86 platform. But when you feed it to the ARM64 compiler, the GCC doesn't know how to interpret it, so it errors out. So the advice here for developers, if you're starting a new project and you want to make your build system cross-compiler friendly from scratch, just put architecture-specific flag in a separate variable one for each architecture. For example, you have some kind of variable in your makefile which defines the target architecture you're building for, and you have compiler-specific flags for x86, you have compiler-specific flags for ARM64, and then your final compiler flags, just you use this pattern and it kind of works. The second symptom we encountered, just broken cross-compilation. So the project compiles natively fine on ARM to ARM, but the cross-compilation is broken, so developers are not very happy about it because they cannot test the build on their local systems. And this usually happens when the compiler outputs need some additional post-processing, like a format conversion. So the output from the compiler needs to be post-processed. And the repository is set up in the way that post-processing tool source is part of the project. And you get similar error, like unrecognized command line option. So to explain what I mean by project setup, so here is a schema or flow of the build I'm referring to. So imagine you have some source files, you have your target compiler, which is usually cross-compiler in. If you're doing cross-compilation, you get some intermediate result, like intermediate output from the compiler. Then you have like additional tools, and they're provided in the source form in the repository, and then you need to compile those tools for your host architecture because you need those tools during the build process. And you get the binaries for those tools, and then you feed the intermediate artifacts to these tools, and then you get the final output. This is a very typical build system setup if you're building a bootloader, because For example, your BIOS doesn't know, so compiler GCC produces an ELF executable, and the BIOS does not know how to run ELF executable, so you need to process this, post-process this output and convert format to the one the BIOS will understand, or do some custom linking or whatever. And so in this case, you basically have two compilers. You have like cross-compiler, and you have like the native compilation for the additional tools. And the cross-compiler itself fails because both of them use generic C flags, like compiler flags, and don't split like compiler flags for target architecture and host architecture. So we encountered this issue is basically in iPXE project, which is a very popular bootloader. We use it in production. And basically, they designed their build system to actually support cross-compilation, but it fails. So probably they never tested it. So they have these workaround flags, and they are defined based on the target architecture, but then they use the same flags for building these host tools, and that part of the build process fails. So again, advice for developers, put architecture-specific flags in a separate variable as before. And so you don't get them mixed up, when you define variables in your build system, always prefix any compiler or linker options with target or host. So you clearly know which compiler flags go to which compiler, like target compiler or the host compiler. Here, DevOps can help as well. So if you're designing a build system which is cross-compiled friendly, why not test it in your CI, right? So apparently for this iPXE project, they had all support for cross-compilation in the build system, but because it was probably never tested, it was broken. And you can also lint project build systems for these advices I'm giving you now, like from non-prefix variable definitions. When I proposed it at work, many people complained that like, oh, why do we need to test cross-compilation if we don't use it yet? It will be a longer build process, but I consider it a feature. Slightly longer build process is kind of giving your developers a chance to relax more. They're very stressed. So the final symptom from compile time problem we encountered, you get broken artifacts. So basically, cross-compilation succeeds, native compilation also works, but the final artifacts are not usable. And again, it usually happens when the compiler output needs additional post-processing, like in the case before. But the difference is these post-processing tools are also released as part of the project. So these tools are needed both during the build process, and they are also released as an artifact. Yeah, so these tools are released as an artifact. And we get error something like that, exact format error, which basically means when we try to run this artifact on the target system, which basically means it was compiled for wrong architecture. And the cause for this is we just mixed up target compiler flags and host compiler flags, or some kind of incorrect build dependency declaration. And we encountered this problem is actually a very unpopular project called Linux kernel. So when you use the native, when you use the cross-compile your Linux kernel to a different architecture, you get broken Linux header Debian package. If you don't know, Linux headers Debian package is needed to compile third-party drivers later for your kernel you're compiling to. And the workflow looks kind of similar as in the case before, but there is additional step where these additional tools are released as another artifact. So basically what happened here is this fixed dep tool is needed to post-process kernel modules. So you compile your kernel modules here, then you need to post-process them, so you compile this fixed dep tool here and to produce your final artifact, your final kernel modules. But also you need to package this tool into this package so people later can compile third-party kernel modules for your kernel. So and here, during your build system, you need this tool for x86 architecture, but you need to package the ARM64 one for later usage. And like Linux build system somehow was screwed up and didn't do that. And it packaged x86 version for ARM64 package. So the advice here is ensure that your all target artifacts are processed with target compiler, not host compiler. And what I like about some projects which are like cross-compiler friendly, for example, if you try to build Android from source, you get all the project output for host and target in a different directory. So you can clearly see which target artifacts have not been compiled for the target architecture. And for DevOps, again, always test your cross-compilation in the CI. And also what you can do is you can probably inspect the final artifacts for anomalies. For example, you had a test in our build script which you can inspect deb packages, and you can see a deb package for ARM64 architecture containing an x86 binary. That's probably something went wrong, and you can catch it in build time. Okay, so we compiled everything and launched it into production. And now we encountered runtime problems. So the first symptom we encountered is the process was complaining about not being able to allocate memory. However, when you log into the system and check the free memory, there's plenty of free memory in the system. You will likely encounter this if the process is using mmap system call for file I/O, like most databases do like that. And in our case, it was a key value store, so kind of a database. And the error looks like this, like enom, it just says cannot allocate memory. To understand what happened here, let's go back to 32-bit versus 64-bit. So 32-bit allows us to address up to 4 gigabytes of RAM, right? Who doesn't agree? With high mem. 64 bits allows you to address up to, I can't pronounce that, but like let's call it more than enough, right? Well, actually the cake is a lie. And it's not about only Linux, every operating system tricks you. But the example from Linux is you don't get all the address space from your bitness of your architecture. So, for example, the way how Linux sets up its memory, you only get you as a user space application, you only get like lower 47 bits of addresses. Then there is a huge hole which is unused, and like these higher bit addresses is reserved for kernel itself, the operating system kernel. So actually, in user space, on 64-bit system, you can only have 47-bit of addressable user space. And that cuts down your addressable space to 1,000, yeah, 128 terabytes compared to promised this, right? But still more than enough. However, on ARM64, if you have a different memory layout, and you actually can have different types of memory layout. But if you take the default one, which we didn't have experience with ARM, we'd say like we will take the default one, which is safe from kernel perspective. It gives you only 39-bit of addresses, and that gives you up to only 512 gigabyte of addressable space. So let's go back to the database case that imagine if your database is large enough, it's more than 500 gigs, which is quite common these days, right? We have a lot of data. You just can't mmap this file because you don't have enough of addressable space. And the error you will receive, it will be exactly cannot allocate memory. Although it doesn't try to allocate memory, it just does not have enough addressable space to mmap the file. So the problem was, this is our like internal code. So the advice here is try to avoid unbounded memory mappings. It's kind of hard. I mean, it's very hard to debug because you just get this cryptic message, right? But if you're a good developer, try to encode the fact, try to check what is the upper bound of a user space addressable space. I'm not aware if there is any portable way to do that, but on Linux you can do that actually, so your software can check what is the upper addressable space of software, and if you're trying to mmap a file bigger than that, you can at least provide a meaningful error message that, well, it doesn't work because this and that. For DevOps, make sure you review your second CPU architecture memory layout. And you might need to recompile the kernel for that, which we did actually. So we chose a different memory layout for ARM64, which gives us 48 bits of user space addresses, which is 256 terabyte of addressable space, which should be fine, right? So it's even more than x86 now. What could go wrong here? And some other workloads started to crash randomly. So we traced it down to Lua code. In Cloudflare, where we are very heavy users of Lua, and we're and like for performance reasons, we use Lua JIT to JIT our Lua code. So introducing you a Lua JIT Lite user data module. It's a simple and efficient C interface. It is efficient because it operates directly on C pointers and stores these pointers in Lua variables. But the module developers somehow noticed that, as we described before, 64-bit platforms have only 47-bit of user space addresses. So when they stored C pointers, they said, hey, we have these like upper bits, which are supposedly always 0, so why don't we use that to store our metadata as well? Yeah, so if you go here, you'll see this like comment. It was very hard to find that on 64-bit platforms you have 47-bit pointers. But they should have written the x86 64-bit platforms, not every 64. Like ARM can have a different type of pointers, right? And in our case, we had 48. In our case, we had 48-bit pointers, so sometimes this higher bit was corrupted, and sometimes the workload crashed. The advice here, please, developers, state your assumptions in code, not in comments. So if you assume your target platform has 47-bit address pointers, check it when you start your process and give a meaningful error message like, I cannot run because this assumption does not hold, right? Don't over-optimize. So like storing metadata in C pointers is maybe is a very extreme optimization case here. And if you do want to optimize, maybe you can provide a fallback less optimal generic implementation if your assumption does not hold and if you check it. Same goes for DevOps here, actually. There is no big difference here. Next type of my favorite optimization is page size. So like if somebody optimizes something, it's somewhere around page size. Who doesn't know what a page size is on a computer? Just in case. So page size is a minimum discrete block of volatile memory of your RAM. So like your CPU doesn't operate on individual bytes, it operates on memory pages, right? And many database like workloads try to keep track of allocated pages. So they give they want like sequential memory access, because like sequential memory access is usually faster. They also want to avoid memory fragmentation. They don't want to rely on the default operating system memory management, so they don't want to blow out memory. They want to keep their data in one place and also do efficient memory reuse. So the symptom we encountered is actually the process uses much more memory on secondary CPU architecture. But otherwise it worked. It didn't crash. Everything worked fine. But it may depend case on case, depending on how aggressive the code with memory management. And the cause for this, the process had hard-coded page size in code. So for x86 platform, the page size is always 4 kilobytes. There is almost never a different page size. But on ARM64, depending on your memory layout, you can have 4 kilobyte pages, 16 kilobyte pages, and 64 kilobyte pages. So what you may end up here if you just hard code your 4K page size. So this how the code roughly looks right on x86 system. When you just transfer this code to ARM64 with 16K page size, you get this picture, right? So you kind of lost everything you've been fighting for. You lost sequential memory access, you lost efficient memory reuse, you're overusing memory, and you have memory fragmentation, so your data is scattered across the RAM. Developers, don't do this. 14,000 exact matches on GitHub as of this, maybe more even, grows. Instead, you can just ask your operating system what is the current page size and runtime and optimize around that. For DevOps, you should definitely monitor your process memory usage on a different architecture when you port your code. The next thing is file system block size. It's like page size, but for files. So this is a minimum amount of any piece of data can occupy on disk, right? So even if you write 1 byte, it will still occupy at least block bytes. It's usually a multiple of underlying block device block size, and typical values for file system are 500 bytes or 4 kilobyte, depending on your underlying storage device. I think for Windows it's called like the cluster size or something like that, if you're from Windows world. And most of the time you don't have to care about the file system block size except for sparse files. Anyone here doesn't know what a sparse file is? Oh, good. A sparse file is a large file, but which is mostly empty. It has a lot of zeros in it, like continuous zeros. And so in most cases, the physical block size, the physical file size is always larger than the logical block size, because 1 byte occupies at least block bytes, right? Except for sparse files. For modding, file systems are smart enough to recognize that the file is contains a lot of zeros, and they don't store zeros on the actual zeros on this. They just store a marker saying, okay, this range is zeros. So in this case, the physical file size is actually smaller than the logical file size. The symptom we encountered is we used a project called Captain Proto, and it had a test suite, and the sparse file test was failing on ARM64. And the interesting thing about this, the test failed only when we run the test suite from TMPFS, which is a RAM-based file system. So on ARM64, it only fails on TMPFS, but if you copy the project to a normal ext4 or XFS file system, it works. The cause was the process had hard-coded block size in code. And on memory-backed file system, which TMPFS, the file system block size is equal to the page size, and we already established that ARM64 may have 4K pages, 16K pages, or 64K pages. So when you copy on ext4 file system, it has a 4K block size, so the test succeeded, but when you copy it to the RAM-based file system, it had like 16K block size, and the test failed. Developers, don't do this. You can ask your file system, what is your block size? And then structure your code around that. This is basically it. So you may notice I never mentioned any assembly here. And most of the examples I given here are written not in C, are written in Go, Python, Lua, any other supposedly cross-platform language. So we can take here that even portable code with no assembly can fail in many ways on different CPU architecture. Advice for developers, don't over-optimize. Always provide a fallback implementation. Try to not rely on assumptions in your code. And if you want to rely on them, test them in code and provide meaningful error output to the operators. for DevOps, set up a CI to test different diverse architectures and configuration, especially cross-compiler. And also you can design tools and linters to enforce best practices, which hopefully I advised here in your code and build scripts. This is how our ARM64 servers look in production now. They're almost indistinguishable from x86 version. Sometimes when an SRE logs in to do some debugging, they don't even know they'll be doing like management of an ARM64 server. That's it. Thank you. The mandatory feedback link, please. And questions? И можно по-русски.
Okay.
Вот очень интересно звучит, что... спасибо большое за доклад, конечно же, я сразу к вопросу приступил. Вот множество из этих pitfalls, да, ну, вот, на что вы наступили, граблей, они же, наверное, известны, да? Может, где-то в сообществе, на самом деле, можно находить вот эти проблемы, их решения раньше, чем мы сами с ними столкнемся?
Ну, мы используем очень много разных open-source проектов. И как бы, ну, все зависит от того, насколько само сообщество использует код на вторичной архитектуре. Вот мне было, допустим, интересно, что вот iPixie загрузчик, который достаточно популярный, у него была просто поломанная вот эта система, билд-система, да, то есть мне тоже было непонятно, почему, допустим, никто раньше этого не заметил. Хотя весь код для кросс-компиляции есть там, да, то есть мы его просто скопировали, попробовали и сразу поняли, почему оно поломано. То есть, наверное, зависит от сообщества. То же самое для ядра Linux. Почему опять это было непонятно? Ну, может, потому что многие не хотят заморачиваться с кросс-компиляцией, потому что я знаю, допустим, Debian, сами по себе они хвастаются, что мы не используем кросс-компиляцию, а мы всегда компилируем наш весь дистрибутив на таргет-платформе, там, делаем native. Поэтому даже большие дистрибутивы иногда не замечают таких проблем.
И еще маленький вопросик. Я, может, как-то невнимательно смотрел. Как slow-JIT решилось? Да, с вот эти вот овер-оптимизация, то есть приходится как-то править и пересобирать сам JIT или... Ну,
это один из модулей, который использовался в других модулях. Просто получилось... там я сам не Lua разработчик, я точно... Это мне как передали информацию. Там был какой-то другой модуль, который вроде как лучше, и на него и так хотели перейти. И как бы это просто подтолкнуло выпилить этот модуль из кода, который мы используем. И все.
Хорошо, спасибо.
То есть, но как бы у нас пару разработчиков, которые участники самого общего Lua комьюнити, они знают проблемы, может, они уже это, по-моему, пофиксили.
Еще вопрос сейчас?
Здравствуйте, спасибо. Было очень круто. Такой вопрос. Было перечислено много моментов, где была проблема с кросс-компиляцией, а может тогда ее просто, то есть вместо локального компиляции просто использовать ремоут-компилятор на таргетовой системе, когда надо. То есть для девелоперов будет почти никакой разницы, просто у них SSH будет вместо обычного баша. Ну и как бы просто огромный пласт проблем должен, по идее, взять и уйти. Вот.
Да, тут вопрос больше, как это все интегрируется в процесс, да, то есть если мы изначально, мы хотим ARM архитектуру, то, конечно, лучше потратить время и все это сразу установить, да. У нас был такой вопрос, что мы думали, нужен ли нам ARM, да, давайте попробуем, нам Qualcomm дал 2 тестовых сервера. И один на который мы должны в продакшн поставить, и один шарить со всеми разработчиками. Это достаточно, они просто его сразу забьют. Поэтому мы давайте идем маленькими шажками, мы начали идти к кросс-компиляции. Конечно, если у вас уже решение есть, все, мы 100% переходим на ARM, вы уже сразу берете инфраструктуру, делаете себе, и, конечно, эти все проблемы уходят. Но вот в таком экспериментальном варианте, то есть мы не хотели тратить много ресурсов на это. Получилось, все равно потратили.
У меня тоже вопрос. То есть вот ты упоминал там разницу по power consumption, а если вот брать какое-то сравнимое оборудование, то есть оно по цене там насколько отличается там в разах там или в попугаях? Примерно, то есть вот эта экономия на самом оборудовании.
Тут, кстати, очень интересный момент. Тут есть, это win-win сценарий называется. У нас был такой план какой, что мы начинаем адоптить ARM64 архитектуру, и мы публично об этом говорим. И, кстати, Qualcomm один из наших инвесторов, они очень были довольны. И мы про это пишем. И то есть в лучшем случае у вас получается два варианта. Вы можете уже брать ARM или x86, и где вы уже там дешевле найдете. В худшем варианте Intel испугался, что мы уйдем на ARM, и они нам дали уже 30% скидки. Поэтому тут cost-effective даже самого процесса уже получается. По оборудованию я точных цифр не знаю, но я знаю, что, допустим, в ARM-экосистеме намного больше всяких производителей, то есть мне кажется, что там больше конкуренции и всегда есть из чего выбрать. И вот этот Qualcomm процессор, он, к сожалению, уже не производится, и он был достаточно дорогой, но все равно дешевле, чем Intel. Есть более дешевые разработчики, которые не такие, конечно, хорошие по перформансу, но, опять же, в зависимости от вашего workflow, может, вам это пойдет. Допустим, я не вижу никакой... Если у вас есть какой-то IO-bound workflow, не CPU-bound, то можно туда полностью поставить ARM-процессор, и вам его хватит с головой.
Окей. Поблагодарим Игната за доклад, оставляем фидбэк. Можно будет с ним обсудить еще какие-то вопросы в зоне для спикеров на 3-м этаже. Спасибо.
Спасибо.